Hello viewers, welcome to Simplified Maths class. Simplified Maths class it is. And today we are taking Statistics Part 3, which is the measures of dispersion, otherwise known as the measures of spread. And in the measures of dispersion, we'll be taking the range, deviation, the standard deviation, and the variance. In this first hour, we'll be concentrating on the range and the mean deviation. Alright? So what is the range? The range is the difference between the highest observed value and the lowest observed value in a given distribution. That's what the range is. And the mean deviation is the mean of the absolute deviations of the given scores away from the mean. That's what the mean absolute deviation is. So we'll be taking some examples. First and foremost, we'll be going into the raw data. Now you might be given this. Given 8, 9, 6, 5, and 7. Then find the range and the mean absolute deviation. Alright, solution. Now I part the range. Of course, we say the range is the difference between the highest observed value, highest score, and the lowest observed value, the lowest score. Alright, so in this distribution, the highest value given is 9, and the lowest observation is 5. That gives us a range of 4, as simple as that. Okay, but if you are asked to find the mean absolute deviation, first we need to find the mean. First find the mean, compute the mean first. Alright, and of course we say the mean x bar is summation x all over n. Alright, so which means our x bar is to add the values 8, 9, 6, 5, 7. 8, 9, 6, 5, and 7. And then divide by how many numbers are given x. That will be 5. Okay, so 8, 9, 6, 5, and 7. So that will be 35. So 35 divided by 5 will give us a mean of 7. So after getting the mean, we are going to apply it to get the mean absolute deviation. So we will need our table of values. After getting this, so we need our table of values for x. After x, needing x minus x bar. Then we need the absolute value of x minus x bar. That's the absolute value, meaning positive values. So our x, we have 8, 9, 6, 5, 7, 6, 5, and 7. Then we'll get our total. Okay, so we need x minus x bar. Remember, we've just computed the x bar to be 7. So we indicate it here 7. So we need x minus x bar. 8 minus 7. That will give us 1. Absolute value is still 9 minus 7. That will be 2. Absolute value is 2. 6 minus 7. That will be negative 1. The absolute value of negative 1 is a positive 1. 5 minus 7. The absolute value is positive 2. And then 6 minus 7. Absolute value is 0. So we add. So when we sum up this, we'll have 6. Therefore, the mean absolute deviation, which is the sum of the absolute value of x minus x bar over n, will be equals to the sum of this, that is divided by n. N, how many data do we have? 5. So 6 all over 5 will give us the mean absolute deviation of 1.2 divided by 5. Alright, 1.2. So you can see why they are called measures of spread. The range give us 4, absolute deviation give us 1.2. They are always far away from each other. They don't come to the data like measures of central tendency. But measures of spread, they are far apart. They are not always together. So that's how we compute the mean absolute deviation and the range for the raw data. Okay, so assuming we are given a frequency distribution and we are asked to find the range and the mean deviation, how do we handle that? Let's go straight to that. That takes us to the second example. All right, so number 2, find the range, which is I, and then II, mean deviation of the table below. All right, in the table, we have our scores, X, and then we have our frequency, F. All right, so we are giving scores such as 20, 22, 25, 30, and 40. Then 8, 4, 5, 7. 8, 4, 5, 7, 24, and 6. All right, so we have to find the range and the mean deviation of this solution. First and foremost, we need the range, and of course the range is the highest observation, the highest score, minus the lowest score. That's our range. So the highest score is 40, the lowest score is 20, 40 minus 20 give us a range of 20. Okay, so we are with the I part, the range. So for us to find the mean absolute deviation, we need to bring out the table of values. So let's bring out our table. So in our table this time we are going to be needing our X. After X we need our F. After F we need our Fx to find the mean. After getting the mean, we'll be needing our X minus X bar. X minus X bar. And then we'll need our X minus X bar absolute value. And then finally we'll need our frequency multiplied by the absolute value of X minus X bar. So we'll be needing this to find the mean absolute deviation. So we need the X, 20, 22, 25, 30, and 40. Okay, that's all. Alright. And then we'll be needing the frequency 648, 648, 5, and 7. So that will be 30. The sum of 30. Let me be sure. Okay, this is 10. Alright, so that's 30. So we need our Fx. 6 times 20. 4 times 22. 25 times 8, 200. 5 times 30. 150. 40 times 7, 280. 40 times 7. Alright, we'll be adding 280 to 150 to 200 to 88 and then 120. So we have a total of 838. 838. That will be the total. So we need that. Alright, so once we are done with that, we need to calculate the mean. The mean is summation Fx all over summation F. So our mean will be summation Fx 838 all over summation F, which is 30. That will give us our mean. We need that mean first. 27.9. So we have 27.9. We need the mean. So we'll indicate the mean here. X bar 27.9. We need that mean to compute what we need. Alright, so at this point, after doing that, we'll be looking for the mean deviation. So let us complete the table. So we have X minus X bar, 20 minus the mean. So we have 20 minus 27.9 minus 7.9. So the absolute value will be positive 7.9. So positive 7.9 times 6, which is the frequency, will give us 47.4. So we are through with that. We take the next 22. 22 minus 7.9 gives us minus 5.9. Absolute value is 85.9 with time by the frequency of 4. So we have 23.6. We take the next one. 5, which is the x, minus 27.9 gives us minus 2.9. We take the absolute value of 2.9 multiplied by the frequency of 8, 23.2. So we take the next one, 30. 30 minus 27.9, 2.1. Absolute value is still 2.1 times by the frequency of 5. So we have 10.5. And then finally 40, we have 40 minus 27.9, 12.1. Absolute value is still 12.1. We multiply the frequency of 7. We have 18.7. So we sum all that. 4.7 plus 10.5 plus 23.2 plus 23.6 plus 47.4. So we have 189.4. Alright, so with this we can now say therefore our mean absolute deviation, which is the same thing as summation f into the absolute value of x minus x bar all over summation f. Alright, so summation f into that will give us 189.4, 189.4 all over summation f, which is 30. We'll then have our mean absolute deviation. Divide 89.4 by 30, that gives you 6.3. So we therefore have our mean absolute deviation to be 6.3, whereas our variance gave us 20. They are far apart, measures of spread. Thank you very much for watching our videos today. We have just completed range and the mean deviation. In our next slide, statistics 4, which is the second aspect of measures of dispersion, we will be taking the standard deviation and the variance for a distribution. And please don't forget that even if you're giving group frequency distribution 1 to 5, that's when the data is group 1 to 5, 6 to 10, 11 to 15, and so on. All you need to is to first convert the group data, the class limit, to x, which of course I've shown you that in statistics 1, which is adding the upper limit and the lower limit. You add them and divide by 2 to give you the x. But once you have the x, every other thing is the same. So the table will only be extended by the class limit. This is the class mark. So that's all. So the same thing is as simple as that. So please, if you enjoyed our video, subscribe to our videos and click on like. Alright, and if you have any question, please don't forget, indicate it in the comment section, and then we'll be giving you the solution to that your question. Thank you very much, and God bless you. And see you in statistics part 4, which is the measures of dispersion 2, and that will be the standard deviation and the variance. God bless you, and thank you once more for always subscribing to our videos. Cheers.